Section 4.4, parallel and perpendicular lines. Essential question. How do you write the equation for a line perpendicular to a given line through a given point? So this lesson is going to focus only on perpendicular lines. Write an example in slope-intercept form for the line that passes through 1, -1, and is perpendicular to the graph of y equals 1/4 x plus 7. So the first thing I'm going to do is graph this equation, y equals 1/4 x plus 7. Rise 1, run 4, rise 1, run 4. All right, so my equation is y equals 1/4 x plus 7. Now what I know about the line perpendicular to it is that first of all it has to go through the point 1, -1. So I'm going to graph that ordered pair, 1, -1. The other thing, this first, so it has to go through the point 1, -1. The other thing I know about perpendicular lines is that their slopes are flipped and changed. So the slope has to flip and change. So let's figure out what our new slope is going to be. Right now it's 1/4. So if I flip it, it'd be 4/1, or 4. And since my original slope is positive, my new slope has to be negative. So the slope of my new line has to be -4. So it's going to be y equals -4x plus something. Okay, so now to figure out my new equation that I have to write, I know a point, I know a slope, so I can put it in point-slope form. So y minus a -1 equals my slope times x minus 1. Get it into slope-intercept form by distributing. So my equation is y equals -4x plus 3. All right, let's graph this new line and see if they end up perpendicular. So I put my first dot on +3, rise -4, run 1, rise -4, run 1. Yes, they were perpendicular. So my new line ended up with an equation of y equals -4x plus 3. When you're all done, make sure, do your slopes flip and change. 1/4 flipped and changed is -4. They have to be flipped and changed. Second one, write an equation that goes through -3/4 and is perpendicular to y equals -2x plus 7. So let's start again by graphing our original line. Rise -2, run 1, rise -2, run 1, rise -2, run 1. So our equation is y equals -2x plus 7. Now I know that my new line has to go through the point -3/4. So I'm going to graph -3/4 and write down that point. Now I also know that perpendicular lines have slopes that are flipped and changed. So let's flip and change -2. So -2 as a fraction is -2/1. So if I flip it, I get 1/2, and my original is negative, so my new slope has to be positive. So my slope is going to be 1/2. All right, I've got a point, I've got a slope, put it in point-slope form. And solve to get it into slope-intercept form. So off to the side here, I'm going to do 1/2 times 3, or 3/1. Now I'm ending up with 3/2. I think it's easiest for your y-intercept to have it as a decimal. So let's turn that into 1.5. Then we can easily add 4 to both sides. And 4 and 1.5 make 5.5. So, 5.5, let's graph that and see what happens. So since it's 5.5, I'm going to go in between here. And I have to rise 1, run 2, and if I go backwards, yes, my line goes through my dot at -3. And then once again, when you're all done, double check and make sure, are my slopes flipped and changed? -2 and 1/2, yes, these lines have to be perpendicular. All right, last one. This time our line is going through, or our line, original line is 2x plus 1. And our new line is going to go through the point 3, 1. So our new line has to go through the point 3, 1. And I also know that my new line has to have a flipped and changed slope. So the slope of my line right now is 2. So if I flip and change that, I'd get -1/2. So my slope has to be -1/2 for my new line. All right, let's take our point and our slope and put it in point slope form. And distribute. So -1/2 times -3/1. So this one again is going to give us a decimal. So I'm going to go up to 2.5 and rise -1, run 2, rise -1, run 2. My line should go through that point. And once again, double check and make sure, are our slopes flipped and changed? 2 and -1/2. Summary.